Welcome back to Algebra 2, Chapter 3, Section 5 in this book. We are talking about graphing linear inequalities in 3 variables. See, I told you were getting something new. Not just x, not just y, but we're adding z. You would use it in things that are 3D. So like if you draw, a 3D figure in geometry, you're using z but didn't really realize it yet. Now, your book's kind of weird. So let me get out my colored pencils to help illustrate this. Normally, y goes up and x goes horizontally. That's our normal coordinate plane. Y-axis up, x-axis across. And so to me, what is logical when we add z, the third dimension, is it should come straight out at you, and we should leave y where it's always been and x where it's always been. And if we were in class together, I would make everybody get out their colored pencils and do this along with me. But your book instead changes it. They turn it where z goes up and where x comes out at you. So they have y going horizontally, z going vertically, and x coming straight out at you. It doesn't really matter what they call them because you do the problem the same way. It's just irritating to me that they just flipped it after all this time. Maybe they know something I don't know. I don't have a doctorate in math or anything, so maybe there's some reason. So now instead of having an ordered pair, we can have an ordered triplet. X, Y, Z. Examine your zipper. Okay, that really was a lame math joke, wasn't it? Okay, so first of all, what we're going to do is learn how to graph an ordered triplet. We have -5, 3, 4, x, y, z. First, you want to graph the x and the y. So, I go on my x, and this is x, is coming out at me this way and going into the paper that way. And I go back into the paper 5. So I go 1, 2, 3, 4, 5. And I can put a little dot there if I want. Next I go y, and y is positive. See, this is positive x, that's positive y, that's positive z, and that's positive y. Y is positive 3, so I go 3 on y. 1, 2, 3. But I have to imagine that it's going back with x like that. You have to be like all perspective-y, and it goes back together. And now from here, I go up 4. I don't start here on 4, I go over here and go up 4. 1, 2, 3, 4. So I draw my line going up 4, and that's about where the point is going to be. Now, in real life, IRL, we do this on computers. Nobody's doing this lame thing that I just did. But that's how you do it, and you're going to have to do it on the test. So, it's just the suffering of the student. Later you get to do it on computer. Alright, so let's do this one. X is 3, so this time I go positive 3 on x, 1, 2, 3. Y is -4, so same thing, 1, 2, 3, 4, but it's got to be, in line, perspective-wise, that's not too good, with the x, okay? So there's and then z is -2, so I go here, and I go down 2, and that's where my point would be, right there. Now, is that exact? No. In real life, we would do this with computers. Now, the next thing you do is you're given an equation, and the form that it normally goes is A's, B's, C's, and then bare numbers, okay? So here's an equation, 3x plus 2y plus 4z equals 12. And we're going to graph it. And how we do it is we do an if-then chart, but it's got 3 columns, x, y, and z. And first we assume that x and y are 0, so x and y are 0. Then what would z be? Well, z would be 12 divided by 4, which is 3. Next, we're going to say x and z are 0, so we cover them up. And what would y be? Y would be 12 divided by 2, so it's 6. And then we say y and z are 0. What is x? Well, x is 12 divided by 3, So it's 4. Now I'm going to graph them. I go to x is 0, y is 0, and z is 3. I go up 3 and put a point. X is 0, y is 6, z is 0, put a point. Then I go to x is 4, 1, 2, 3, 4, and put a point. Last, you connect your points and color the triangle. Not terrible. That's so fancy looking, and it's actually easy, isn't it? All right, here's another one. You'll have an equation, and you're given instructions like write a linear equation as a function of x and y. All that is saying in the fanciest math talk they can come up with is solve for z. And how do we solve for z? By doing the opposite. So, y is z not alone. It's got a 4, a 3x, and a 2y. So I'm going to subtract the 3x and 2y from both sides. These cancel out, and then I'm left with 4z equals negative 3x minus 2y plus 12. Y is z not alone. It's being multiplied by 4, so what's the opposite? Divide by 4. Who gets divided by 4? Everybody! It's a pirate party. Divide by 4, divide by 4, divide by 4. These cancel out. So z equals negative 3/4 x minus 1/2. 2/4 reduces to 1/2 y plus 3. Now your book only half does the problem, and they make it look all hard and weird. Mine is better. Mine, I can honestly say, is better because math etiquette, you do x's, then y's, then bare numbers, and they did not follow math etiquette. I don't know where they get off thinking they can just throw the etiquette out. Okay, that was my Emily posted math moment. All right, bye guys, smiley face. So then the other thing they said, evaluate when x equals 1 and y equals 3. All that means is you substitute 1 in for x, y in for 3, and do it. So 1 times negative 3/4 is negative 3/4. 3 times negative 1/2 is negative 3/2 plus 3. You can do it in your calculator or do the fractions, and it equals 3/4. One way you might have to tell your answer as an ordered triplet, it would be 1, 3, 3/4, x, y, z. All right, that looks so fancy, but it's really easy, isn't it? Math is great. See you next time.